In this video, I'm going to go over a couple weird examples or weird situations with integration by parts. So looking at this one, for example, the antiderivative of the natural log of x, we don't know that. We know the derivative of the natural log of x. We don't know the antiderivative of the natural log of x. So that's one weird thing. The other weird thing is, how would this be integration by parts? It seems like there's only one part, and then one part is the natural log. Well, there actually are two parts. We've got the natural log of x, and we have dx. Now, normally I say that v prime is the more complicated, but in this case, if we let v prime equal the natural log of x, we run into that same situation where we can't find the antiderivative. So I'm going to let u equal the natural log of x, and I'll let v prime be the dx. Okay, so u is the natural log of x, v prime is dx, or just 1 dx. The derivative of the natural log of x is 1 over x. The antiderivative of dx is just x. All right, if we use integration by parts then, it's u times v minus the antiderivative of u prime v. All right, if I simplify that 1 over x times x, it just gives me 1. And the antiderivative of 1 is x. Okay, so that's one weird situation. Let's look at another one. These are absolutely my favorite types of problems. I love this. Let's see, let's use x squared cosine x dx. I want you to go give this a try. Try using integration by parts to find the antiderivative of x squared cosine x dx. I'll see you in a second. Okay, welcome back. If I let u equal x squared, then I'm going to let v prime equal the cosine of x, because cosine of x is a little bit more complicated than x squared is. So now that means u prime is 2x, and v is sine x. Okay, if I rewrite this, then I've got x squared cosine x dx. U times v is x squared sine x minus the antiderivative of u prime v, which is 2x sine x. But we have an issue. In order to find the antiderivative of this, we have another product. We have a 2x times the sine of x. So I hope that you thought about this. What we need to do then is use integration by parts again. Okay, so I'm going to let u equal 2x. U prime is 2. Let v prime equal sine x. And v is negative cosine x. Now here's the trickiest part of all of this. When we rewrite this now, we've got this whole thing being subtracted. So we're going to use integration by parts again. So when we find the antiderivative of this, we need to subtract the entire integration by parts. So I'm going to multiply u times v, that's negative 2x cosine x, minus the antiderivative of u prime v. And u prime v, that gives me negative 2 cosine x. I'm going to deal with all of these negatives now so I don't have to think about it later. Got x squared sine x minus the negative 2x, so this becomes plus 2x cosine x. And then this is negative and this is negative, that becomes plus. But then if I distribute that negative, it becomes minus. So minus the antiderivative of 2 cosine x. Okay, now that I've done all of that, I can write my final answer, because now I can find the antiderivative of 2 cosine x, and that is 2 sine x. So it's minus 2 sine x plus c. So we got to use integration by parts twice in one problem. Kind of cool. Okay, last one. This one is the best. I'm going to create quite a bit of space on this one. This one I'm going to say Let's do e to the negative x cosine x dx. Now this one's kind of a toss-up. Which one's u, which one's v? I'm going to let v prime be e to the negative x, and then I'm going to let you go try this. So pause, go give it a try. Okay, welcome back. This one turned out to be, I like to call this is the problem that never ends. It just kind of loops. So I'm going to let u equal cosine, which means u prime is negative sine x. Positive and negative signs are really important in this problem. The antiderivative of e to the negative x, because we need to use u substitution on this one. U is the exponent, du is -1. So the antiderivative of this is negative e to the negative x. Be very careful with that. Okay, if I rewrite this, I've got e to the negative x cosine x dx equals u times v. Oops. Minus u prime v. So that's negative sine x times negative e to the negative x. That's then positive e to the negative x sine x. All right, we've got another product here. We've got e to the negative x and sine x. So I'm going to let u equals sine x. U prime is cosine x. V prime is e to the negative x. V is negative e to the negative x. Okay. E to the negative x cosine x dx equals negative cosine x e to the negative x. And I hope you're thinking, aren't we just going to keep going in circles? And yes, we are just going to keep going in circles. So let's just keep going and see what happens. All right, u times v, negative e to the negative x. Actually, I'll write it in the same order as everything else. Sine x e to the negative x minus u prime times v. So that's negative e to the negative x times cosine. So this becomes plus e to the negative x times cosine. All right, if I distribute that negative then, got negative e to the negative x cosine x minus a minus, so that's plus e to the negative x sine x minus the antiderivative of e to the negative x cosine x. Now if we did integration by parts again, we're just going to keep going in circles. It's just going to keep spiraling between sine and cosine. But this is why I ask you to rewrite the original, because if you'll notice, this value on the left side, those are like terms. Those are both the same integral. So if I add this antiderivative to both sides of the equation, I end up with two of these then. Oops, I need to write the rest of it. Don't forget the constant. But the goal was to find just this antiderivative. So if we can isolate that antiderivative, then we'll have the answer we're looking for. So I'm going to divide this entire equation by 2. That'll give me -1/2 e to the negative x cosine x plus 1/2 e to the negative x sine x. Half of a constant is still constant. So there's your antiderivative. Love this problem. It's like the problem that never ends, but you need to look for that pattern when it starts to repeat itself and you get the same thing that you started with. So keep that in mind. Okay, that's enough.